acids and bases, pH and pOH of strong acids and bases. In this video, we'll define pH in terms of a hydrogen ion and the hydroxide ion concentrations. We'll also define pOH in these terms. We'll identify the relationship between H+ and OH- and discuss how one pH unit relates to hydrogen or hydroxide concentrations. Before getting into pH and pOH, let's look at what the concentrations of H+ ions are in some common household solutions. For instance, if we had neutral water, the H+ concentration is 10 to the negative 7th, while the OH- concentration is also 10 to the negative 7th. In something like lemon juice, the H+ concentration has now increased to 10 to the negative 3rd, while the OH concentration is 10 to the negative 11th. And for something like household ammonia, which is used as a cleaner, we have H+ is 10 to the negative 11th now, so much smaller than neutral water, and the OH- concentration is 10 to the negative 3rd. I'd like to point out that these all multiply to be 10 to the negative 14th, which will be a pretty important number to us this quarter. We'll talk more about that later. Something you may have noticed right away is that these numbers are not, shall we call it, conversational. 10 to the negative 11th does not roll off the tongue. It would be easier if we had a simpler way of talking about these numbers. And since they vary by very large exponential quantities, given the 10 to the negative on each one, we can simplify the numbers by taking the negative log of each of them. And in fact, this is very close to what pH and pOH will be. However, if we simply take the negative log of the number, that would leave us with negative numbers. And since we are attempting to make life easier, we may as well get rid of the negative. So we'll take the negative log of each number. We talked about pH earlier in terms of defining what is an acid or a base in the simplest possible way. We have since defined acids and bases in terms of hydrogen ions donated or accepted. Now let's define pH in terms of these hydrogen atoms, as well as introducing a concept called pOH. pH is the negative log of the hydrogen ion concentration. And similarly, pOH is the negative log of the OH- concentration. So when you see this P with something followed after it, you'll know to take the negative log of it. At 25 degrees Celsius, these are always going to add to be 14, in much the same way that earlier in the video, we saw that H+ and OH- concentrations multiplied to be 10 to the negative 14th. So this will be a very useful equation to convert between pH and pOH. Let's look at something that we've spoke of a couple of times now, in terms of a graph. Due to the ionization of water, the concentrations of H+ and OH- are related. We saw this in examples of water, lemon juice, and ammonia, where each H+ and OH- concentration multiplied to equal 10 to the negative 14th. This means that as one species goes up, the other must go down. In an acidic solution, we have a higher H+ concentration, which means we have a lower OH- concentration. Bases, on the other hand, have a higher OH- concentration and therefore a lower H+ concentration. Do note that I say this for 25 degrees Celsius. This does change slightly depending on the temperature. Let's talk about some practical implications of a logarithmic scale. If we look at soda, it has a pH of 3, which means that its H+ concentration is 1 times 10 to the negative 3rd. If we compare that to tap water, which is often around pH 6, we can see that the H+ concentration decreases to 1 times 10 to the negative 6th. So 3 pH units was actually 1,000 times difference in H+ concentration. And in fact, due to how logarithms work, every pH unit is not increasing a concentration of H+ by 1, but actually by 10. So something that is 1 pH unit lower has 10 times the H+ concentration. Hopefully after watching this video, you can now define both pH and pOH in terms of the hydrogen ion and hydroxide ion concentrations. You know the relationship between H+ and OH-, and you understand how a logarithmic scale means that one pH unit is related to the hydrogen or hydroxide concentrations.